A local woman died after a venomous ant stung her.
So scary. It's an invasive species in Georgia posing a growing risk to people.
Something is moving beneath your feet right now. Not one thing. Millions of things. Moving in formation. Hunting. Building. Enslaving. Waiting. Ants have been on this planet for 140 million years. They were here before the dinosaurs went extinct. They watched empires rise and fall, and in that time, they evolved into something we still don't fully understand. Organisms so precisely engineered that scientists study them to build better robots, develop new painkillers, and rethink everything we assumed about intelligence without a brain. But today isn't about the science. Today is about the ones that kill, the ones that have left scientists speechless, the ones that have emptied entire villages, skeletonized prey larger than a house cat, infiltrated foreign colonies through psychological warfare, and been confirmed to take human lives. 10 species, 10 strategies, each one deadlier than anything you'd expect from something you could crush under your thumb. Number 10. Siafu, confirmed to have killed humans. There is a rule in the African bush. When the Siafu come, you move. You don't investigate. You don't watch. You don't assume your home is safe. You move. Siafu, also called African safari ants, or Doralus wilverthi, are, by any clinical measure, the most dangerous ants in the world when it comes to confirmed human fatalities. Unlike species feared for their venom or their sting, the Siafu don't need either. They kill through something far older and more brutal: sheer mass. A single Siafu column can number 22 million individuals. When they move through a landscape, they move as one coordinated organism, spreading across the forest floor in a fan up to 50 meters wide, consuming everything that cannot escape. Lizards, frogs, nesting birds, rats, anything immobile, anything sleeping, anything trapped. The confirmed human deaths are not myth, they are documented. Most victims share one thing in common: they were unable to move. Infants left unattended, elderly men and women who couldn't wake fast enough. A drunk man in Tanzania who collapsed near a nest and was found the next morning, not decomposed, but stripped. The mandibles of the soldier Siafu are so powerful, they are used by some African tribes as emergency sutures. A soldier ant is pressed against a wound. Its jaws clamp shut across the skin, and then the body is twisted off, leaving the locked mandibles in place as natural stitches. The ant dies. The wound closes. Let that settle for a moment. The same jaws used to kill are used to heal. The same creature that empties a birdcage in minutes is used as a medical instrument by people who have lived alongside it for generations. Siafu colonies operate on a cycle. During the stationary phase, the queen lays up to 1 million eggs in a single month, the highest egg production of any creature on Earth relative to body size. During the nomadic phase, the colony packs up, moves, and devours everything along its route. They have no fixed home. They are always moving, always consuming, always expanding. One detail that left researchers quiet for a long time: Siafu soldiers are completely blind. Every single one of them. This colony, 22 million strong, coordinated enough to strip a carcass in minutes, operates in total darkness, navigating entirely through chemical signals and vibration. No eyes, no central brain, just a network of pheromone instructions so precise it produces behavior that looks, from a distance, like military strategy, because it is. Number 9. Driver ant, the swarm that resets ecosystems. If the Siafu are the executioners, the driver ant is the architect of destruction. Doralus, the driver ant, is found across Central and East Africa, and it operates at a scale that reframes what a single species can do to a landscape. Scientists don't just study driver ants for their aggression. They study them because what happens after a driver ant column passes through is, in ecological terms, a reset. The pests are gone, the diseased animals are gone, the carcasses have been processed, the soil has been aerated. What looked like an apocalypse produces, within days, a forest that is measurably healthier than before. But first, the apocalypse. A driver ant column in full nomadic phase is unlike anything else in nature. Picture a living river, not water, but 20 million individual bodies flowing across the jungle floor, climbing trees, crossing gaps by forming bridges out of themselves, moving with no central command and perfect coordination. No general, no map, no plan that any individual ant is aware of. Just pheromone signals, invisible chemical instructions passing from body to body, producing movement that from above looks deliberate, organized, and terrifyingly purposeful. Their raids begin at dawn. Scouts fan out in a wide formation. The moment one scout's antenna detects prey, movement, heat, the carbon dioxide of breath, the signal spreads. Workers converge, soldiers take position on the edges, and the swarm closes in. A lizard that doesn't move fast enough, gone in under a minute. A grounded bird, skeletonized in 3. Even snakes have been found after driver ant raids. Not injured, not frightened away, but completely stripped, their bones scattered and clean. Driver ant soldiers are equipped with scissor-like mandibles that cut through skin, fur, and light fabric. They don't sting, they don't need to. The damage is mechanical. Thousands of individual cuts delivered simultaneously, faster than any prey can process and respond to. Their colonies are nomadic. They have no fixed nest. Between raids, they build a bivouac, a living structure made entirely from their own bodies. Workers interlock legs and jaws, layering themselves into walls, tunnels, and chambers that house the queen and her brood. Temperature, humidity, ventilation, all regulated by the constant movement of the ants themselves. Then, when it's time to move, they simply disassemble. The city picks itself up and walks away. In rural Africa, the arrival of a driver ant column is enough to empty a house. Windows are sealed. Food is lifted off the floor. Fires are sometimes lit around doorways to create a heat barrier. And yet, the same communities that fear them also respect them, because they know what the forest looks like after the swarm has passed. Cleaner, quieter, and ready to grow again. Number 8. Army ant, the colony that builds itself. The driver ant is African. This one is South American. Same principle, different execution, and in some ways the more disturbing of the two. Argentine burchellii, the army ant of the Amazon, is the species that made biologists stop using the word instinct so casually. Because what army ants do doesn't look like instinct, it looks like engineering. When an army ant colony encounters a gap, a break in the forest floor, a space between branches, a hole in the canopy, the workers don't go around it, they fill it. Scouts reach the edge and stop. Others climb on top of them, then more climb on top of those. Within minutes, a living bridge spans the gap, ants locked together by hooked feet and interlocking legs, forming a structure strong enough for the rest of the colony to walk across. When the last ant has crossed, the bridge dismantles itself. The ants that formed it fold back into the column and continue marching. They built a bridge, used it, then absorbed it back into the army. Army ant raids in the Amazon are circular. The colony moves in a rotating spiral, sweeping an area clean and then moving on before they run out of prey. They take everything: insects, spiders, scorpions, small reptiles, the occasional nestling bird. Anything in the path of the raid either flees or is consumed. But here is the detail that made researchers genuinely reconsider what insect intelligence means. Army ants optimize their bridges in real time. If the bridge is too long, ants in the middle shift position to shorten the angle. If traffic is heavy, the bridge widens. If it's light, it narrows. No individual ant is making these decisions. The bridge adjusts itself, a collective calculation performed by thousands of bodies simultaneously, without any of them knowing what they're solving. Engineers studying swarm robotics have spent years trying to replicate this. So far, nothing built in a laboratory matches what Argentine burchellii does without thinking about it. The colony also has 2 distinct phases. During the stationary phase, the queen lays up to 300,000 eggs. During the nomadic phase, the colony raids. The transition between phases is chemical, triggered by the hatching of larvae and detected simultaneously across the entire colony. One signal, 2 million responses, instant. There's no word for what army ants are that doesn't undersell them. They're not just insects. They're a distributed intelligence, a single organism spread across 2 million bodies, building infrastructure, making collective decisions, and reshaping the rainforest floor every day they exist. Number 7. Bullet ant, the sting that burns for 24 hours. There is a scientific index that ranks the pain of insect stings. It runs from 1 to 4. A honeybee is a 2. The bullet ant is a 4, not a high 4, not an upper 4. The ceiling, the top of the scale. The point at which Dr. Justin Schmidt, the entomologist who built the index by getting stung by everything he studied, described the experience as, and this is a direct quote, like walking over flaming charcoal with a 3-inch nail embedded in your heel. He got stung so many times in the name of science that he won an Ig Nobel Prize in 2015. He has been stung by more species than almost any human alive, and the bullet ant still sits at the top of his list. Paraponera clavata, named for its thick club-shaped body, lives in the rainforests of South and Central America. It is one of the largest ants in the world, 2.5 centimeters long, dark reddish-black, with mandibles and a stinger that looks, under a microscope, less like a biological feature and more like a weapon someone designed specifically to cause suffering. The venom is called ponerotoxin. It is a neurotoxic peptide that targets voltage-gated sodium channels in the nervous system, the biological equivalent of cutting the off switch for pain signals. Once ponerotoxin enters the bloodstream, pain signals cannot be shut down. The burning, which begins within seconds, peaks at around 2 hours and lasts for a full 24. Some people report tremors. Some report temporary paralysis. Some report hallucinations in the hours following a sting. All of them agree it is unlike anything else they have ever felt. And yet, the bullet ant is not aggressive. It doesn't patrol for targets. It doesn't pursue. It lives in small colonies of 700 to 1,000 individuals, nesting at the base of large trees, and it generally wants nothing to do with anything larger than a termite. Threaten the nest, and that changes instantly. There is a ritual among the Satare Mawe people of the Amazon that involves bullet ants. Young men must wear gloves woven from leaves in which hundreds of living bullet ants have been sewn, stingers facing inward, and wear those gloves for 10 minutes as part of an initiation ceremony. The stings begin the moment the gloves go on. The ceremony must be completed without showing pain, and it must be completed not once, but 20 times before the initiation is considered finished. The young men who complete it often lose feeling in their hands for days. Some experience paralysis lasting weeks. They do it anyway, because in their culture, the bullet ant's sting is not just a test of pain. It is a test of what you will endure to become who you want to be. Number 6. Fire ant, the colony that survived a hurricane by becoming a raft. In August 2017, Hurricane Harvey made landfall in Texas. Streets flooded, homes disappeared underwater, and drifting through the brown debris-filled floodwater, moving with eerie calm, were islands. Not wood, not plastic, living islands. Masses of fire ants, linked together, floating. People who waded through the flood reported them. Scientists who studied them afterward were quiet for a while, because what fire ants did during Harvey wasn't survival. It was engineering, and it worked so well that researchers who study materials science, not biology, started paying attention. Solenopsis invicta, the red imported fire ant, is native to South America. It arrived in the United States in the 1930s, almost certainly as a stowaway in cargo through the port of Mobile, Alabama. Within decades, it had spread across the entire southern United States. It is now established in China, Australia, and parts of Europe. It is one of the most invasive species in recorded history, and it costs the United States alone an estimated $8 billion annually in agricultural damage, medical treatment, and infrastructure repair. The fire ant's weapon is its sting, technically both a bite and a sting, delivered simultaneously. It bites to grip, then pivots its body in a circle and stings repeatedly, injecting solenopsin, an alkaloid venom that causes an immediate burning sensation, followed by raised white pustules that can last for days. In people with severe allergies, a handful of stings can trigger anaphylactic shock. But the sting is not what makes fire ants extraordinary. It's their chemistry. Every decision a fire ant colony makes is governed by pheromones, invisible chemical signals that function as orders, alarms, maps, and messages simultaneously. One ant finds food. It lays a scent trail back to the nest. 1,000 ants follow it. One ant detects a threat. It releases an alarm pheromone that reaches every ant in the area within seconds. The colony responds as a single organism. There is no delay, no miscommunication, no ant stops to think. And when disaster comes, when the flood rises faster than the colony can escape, they don't drown, they don't scatter, they link together. Each ant grabs its neighbor with hooked feet and interlocking mandibles, and the colony forms a living raft. Buoyant, flexible, self-healing. The queen and larvae are held in the center, protected. The ants on the outer edges rotate constantly, ensuring no single ant stays submerged long enough to drown. If you poke a hole in the raft, the ants rush to fill it. The structure repairs itself in real time. Materials scientists who studied fire ant rafts found that they behave less like a collection of insects and more like a non-Newtonian fluid, a material that changes its properties in response to stress. Poke it and it stiffens. Leave it alone and it flows. Nothing humans have ever engineered does this as efficiently at this scale with this little energy. The fire ant is not the most venomous ant on this list. It is not the largest, it does not have the fastest strike or the most disturbing social behavior, but it might be the most successful creature on Earth. And that, in a world where success often comes at other species' expense, makes it one of the deadliest things in nature. Number 5. Argentine ant, the supercolony that spans 3 continents. Everything on this list so far has been deadly in ways you can see. A swarm, a sting, a mandible, something visible, measurable, immediate. The Argentine ant is deadly in a way that took decades to notice. Linapithema humile, a small, brown, unremarkable ant native to Argentina, has built the largest cooperative structure ever documented in the natural world. Not a nest, not a colony, a supercolony. A single interconnected network of ants stretching from the Mediterranean coast of southern Europe through most of California and into coastal Japan. 6,000 kilometers, hundreds of billions of individuals, all behaving as members of the same colony. When scientists took Argentine ants from California and introduced them to ants from the same supercolony in Europe, colonies that had been geographically separated for decades, the ants recognized each other as family. No aggression, no conflict. They touched antennae and went about their business. When they introduced Argentine ants from a different supercolony, a smaller separate network also present in Europe, the ants fought immediately. The chemical signature of shared identity, produced by diet, environment, and genetics interacting over generations, had been maintained across an ocean, across decades, without any physical contact. The ants didn't know each other, but their chemistry said they were family. And chemistry, for ants, is everything. The Argentine ant doesn't kill through venom or swarm predation. It kills ecosystems. Wherever it establishes, native ant species collapse. The ecological roles those native species filled, seed dispersal, soil aeration, predator-prey balance, disappear with them. In California, the Argentine ant's expansion has been directly linked to the decline of several coastal horned lizard populations, which depend on harvester ants for food. The harvester ants are gone. The lizards are starving. The Argentine ant didn't touch the lizards. It didn't need to. It rewrote the menu. The Argentine ant spreads through human infrastructure, in soil attached to plant shipments, in cargo, in goods. Every time a human moves something across a border, there's a chance a few Argentine ants come with it, and a few is all they need. A single mated queen can found a new colony. Within years, that colony connects to the nearest existing supercolony and expands the network further. They have been on every continent except Antarctica. They are still spreading. No single ant on this list has affected more species, more ecosystems, and more of the planet's biological balance than this one, and most people have never heard its name. Number 4. Slave-making ant, the empire built on stolen lives. Somewhere in the undergrowth, a colony is going about its day. Workers tend larvae, soldiers guard the entrance. The queen lays eggs. Everything looks normal. It isn't. The workers are not who they think they are. The queen they serve is not their queen. The larvae they are raising will one day enslave more of their kind. This is the world of Polyergus rufescens, the slave-making ant, and it is one of the most disturbing biological systems ever documented. Polyergus ants do not build. They do not forage. They do not clean their nest or care for their young. They have evolved so completely into a parasitic lifestyle that they have literally lost the physical ability to do any of these things. Their mandibles, curved, blade-like, built for one purpose, are weapons. Nothing else. A Polyergus ant placed alone, away from its slaves, will starve to death surrounded by food it cannot pick up. Without slaves, the colony dies in days. It begins with a queen. A newly mated Polyergus queen leaves her birth nest and locates a target. A Formica colony, a different species, a functioning society. She approaches alone, and here is where it becomes something that doesn't feel like it belongs in the insect world. She doesn't attack, she infiltrates. Her body is coated in chemical compounds that mimic the Formica colony's own scent signature. She enters the nest. The workers, following their pheromone-based recognition system, the only identity system they have, detect nothing wrong. She smells like family. They let her pass. She finds the Formica queen. She kills her. Quickly, efficiently, without alarm. Then she begins laying her own eggs. The Formica workers, still under the chemical illusion, begin raising Polyergus larvae as their own. The colony continues to function. The infrastructure is intact. The workforce is intact. Only the queen has changed. And by the time the first generation of Polyergus workers matures, The colony is already under foreign control. When more workers are needed, the Polyergus soldiers raid neighboring Formica nests. They march in formation, release chemicals that disorient the defenders, kill the adults, and steal the pupae. The stolen pupae hatch in the Polyergus nest, imprint on its scent, and spend their lives serving the colony that enslaved them. They guard it, they feed it, they raise the next generation of raiders that will one day enslave more of their kind. But here is the part that surprised researchers most. Some enslaved ants fight back. Not openly, they cannot. But subtly, inside the nest, enslaved workers have been observed killing Polyergus pupae at higher rates than their own kind. Not enough to collapse the colony, but enough to slow it. Enough to protect, in a small, invisible way, the next generation of their own species from the same fate. They are slaves who found the only form of resistance available to them, and they took it. Number 3. Weaver ant, the war machine that farms its own silk. High in the trees of Southeast Asia, something is happening that most people walk directly underneath without ever looking up. A war is being fought, in the canopy, quietly, continuously, and the side that wins controls everything below it. Oecophila smaragdina, the weaver ant, is not the most venomous ant on this list. It doesn't have the fastest strike or the most dramatic kill. What it has is something rarer and, over the long run, more powerful. Perfect territorial control. Weaver ant colonies spread across multiple trees, connected by branches and pheromone highways, housing hundreds of thousands of individuals in an elevated empire. The nests themselves, green, sealed pouches built from living leaves, are architectural achievements that took biologists years to fully understand. The construction process works like this. Adult workers form living chains, gripping each other's legs and pulling leaf edges together with their jaws. Once the leaves are close enough, another worker arrives carrying a larva, held gently in its mandibles, and moves it slowly back and forth across the gap. The larva produces silk. The leaves are stitched shut. Workers who don't produce silk yet serve as living scaffolding. When the nest is sealed, the team disperses and begins the next section. They built a waterproof structure using larvae as tools and their own bodies as machinery. No blueprint, no supervisor, just chemical signals and 200,000 years of refinement. The nest is also a fortress. Older workers maintain outpost nests at the edges of territory, early warning stations that detect intrusion and raise the alarm within seconds. The alarm is chemical. The response is immediate. Soldiers converge from multiple directions simultaneously, cutting off retreat, attacking from above and below. Weaver ants have no stinger. They compensate with mandibles sharp enough to cut through insect exoskeleton, and while those mandibles are locked in, they spray formic acid directly into the wound. The combination, mechanical damage and chemical burning, is enough to drive off predators many times their size. When two weaver ant colonies meet at a territorial boundary, what follows looks less like an insect encounter and more like a military engagement. Coordinated advances, strategic retreats, flanking movements. Colonies that are losing will sometimes relocate their queen before the boundary collapses, preserving the leadership while sacrificing the front line. Farmers in Southeast Asia have known about weaver ants for over 1,000 years. Records of their use as biological pest control in citrus orchards date back to at least 400 AD in China. The ants patrol trees, eliminate caterpillars, beetles, and anything else threatening the crop. In return, farmers leave the nests alone. The arrangement works, but it comes with conditions. Reach into a tree occupied by weaver ants, and you'll know about it for hours. They are not your allies, they are contractors, and the contract is entirely on their terms. Number 2. Bulldog ant, Australia's most dangerous ant, and the one that sees you coming. Of course it's from Australia, a country where the spiders are large enough to eat birds, where the jellyfish can kill in 4 minutes, where the inland taipan produces enough venom in a single bite to kill 100 men. Of course, this country also has the most dangerous ant on Earth. Myrmecia piriformis, the bulldog ant, is everything an ant is not supposed to be. It is large, up to 40 millimeters, roughly the length of your thumb's first joint. It has enormous compound eyes, not the flat, nearly blind sensors of most ant species, but functional high-resolution vision that can track movement from over a meter away. It has long, blade-like mandibles serrated like a saw. It has a stinger with no barb, meaning it can sting repeatedly without dying, and the venom it delivers is, per milligram, one of the most toxic produced by any insect. 3 confirmed human deaths in recorded history. The most recent, a farmer in Victoria in 1988. Cardiac arrest, triggered by anaphylaxis, from a single sting, from an ant the size of your thumb. The bulldog ant's hunting behavior is what separates it from everything else on this list. It doesn't swarm, it doesn't raid in columns or wait for chemical signals to coordinate an attack. It hunts alone. It tracks prey with those compound eyes, locks on, and closes the distance with a speed that looks wrong for something its size. Some bulldog ants, called jumper ants, launch themselves at threats in short, aggressive leaps, covering ground faster than most prey can register the movement. When it attacks, the sequence is precise. Mandibles lock onto the target first, gripping through exoskeleton or skin. Then the abdomen curls forward and the stinger drives in. If the prey moves, the mandibles tighten. The ant doesn't release until the sting is complete. Then it pulls back, reassesses, and if the threat remains, it stings again. There is footage, studied closely by entomologists, of a single bulldog ant engaging a huntsman spider more than twice its body weight. The ant doesn't hesitate. It closes, takes the spider's defensive strike, locks on with its mandibles, and begins stinging methodically. The spider twitches, then slows, then stops. The ant drags the body toward its nest without pausing. This was a spider that could kill a mouse. The ant took it alone. The bulldog ant's venom is now the subject of serious medical research. Its biochemical complexity, proteins, histamines, and neurotoxic compounds in a ratio not seen in other ant species, is being studied for applications in pain receptor research and new analgesic development. The thing that causes the pain may also help scientists stop it. Bulldog ants are not aggressive without cause. They don't patrol for targets. Near their nest, they are alert, watchful, and fast. Away from it, they are, by ant standards, relatively measured. But their nest is underground. The entrance is small, almost invisible, and the tunnel below it runs several meters deep, housing a colony ready to pour out in disciplined waves within seconds of a disturbance. Walk carefully in Australian gardens. Look before you kneel. And if you see a large ant watching you from a meter away with eyes that don't look like insect eyes, back away slowly. It already knows you're there. Number 1. Trapjaw ant, the fastest moving body part in the animal kingdom. Everything on this list has been impressive. Some of it has been disturbing. A few entries have been genuinely hard to shake. But this one is different, because the trapjaw ant doesn't just kill efficiently. It does something that, when you see it for the first time on high-speed camera, makes you stop and watch again. Because it doesn't look like biology. It looks like engineering, like something that was designed. Odontomachus baueri, the trapjaw ant of Central and South America, has jaws that close at 145 miles per hour. That is not a figure rounded up for drama. That is the measured velocity, confirmed by multiple high-speed camera studies, of the fastest moving body part ever recorded in the animal kingdom. Faster than a dragonfly's wing. Faster than a mantis shrimp's strike. Faster than anything in any species that has ever been accurately timed. To put it in terms that means something, a human blink takes between 100 and 400 milliseconds. The trapjaw's mandibles close in 0.13 milliseconds. By the time your eye has begun to close, the ant has already struck, withdrawn, and is assessing whether to strike again. The mechanism is not muscle-driven. No muscle on Earth contracts fast enough to produce this speed. Instead, the trapjaw uses a latch system. Slow, powerful muscles spend several seconds loading elastic energy into a catch structure like drawing a crossbow. Trigger hairs on the inner edge of each mandible serve as the release. The moment a prey item brushes against one, the latch releases, and all that stored energy discharges in a single, controlled explosion. The force at impact: over 300 times the ant's own body weight. The prey, usually a termite, a springtail, or a small beetle, is either crushed instantly or stunned. A venomous sting follows. The hunt is over before the prey's nervous system has finished registering that contact occurred. But the jaw is not just a weapon. When threatened by a predator, an ant lion, a spider, something it cannot fight, the trapjaw ant angles its head downward, positions its mandibles against the ground, and fires. The recoil launches the ant backward into the air, propelling it up to 8 times its body length in a single explosive leap. It's not a controlled jump, it's an ejection. The ant tumbles through the air, lands somewhere in the leaf litter, and is gone before the predator can reorient. When multiple trapjaw ants do this simultaneously, which happens when a colony is threatened, the effect is described by researchers as a dizzying spectacle of motion. Ants firing in every direction, ricocheting off leaves and stems, vanishing into the undergrowth. Predators don't just miss, they lose track of the entire colony. Here is the detail that elevates this from impressive to extraordinary. The trap jaw mechanism has evolved independently at least 4 times in different ant lineages. 4 separate evolutionary paths, across 4 different parts of the world, arrived at the same mechanical solution, a spring-loaded latch triggered by sensory hairs, releasing elastic energy through a rotating jaw. Scientists call this convergent evolution, nature independently inventing the same design because the design is simply that good. Engineers studying micro-robotics, surgical instruments, and rapid-release mechanisms have spent years analyzing Odontomachus jaws. The efficiency, the ratio of energy stored to energy released, the precision of the trigger, the control of the strike direction, has not yet been matched by anything built in a laboratory. The fastest-moving body part in the animal kingdom, a weapon that doubles as an escape system, a design so effective that evolution built it 4 times, and an ant small enough to lose in a crack in the floor. Nature doesn't build things without reason. Every feature on this list, every swarm, every venom, every chemical deception, was shaped by millions of years of pressure and response. These ants are not accidents, they are solutions. Perfect, ruthless, endlessly refined solutions to the problem of survival in a world that is trying, constantly, to kill them. They've been winning that problem for 140 million years. We've been watching for about 100. If this video changed how you think about what's moving beneath your feet, share it. And if you want more of this, you know where to find us.